Okay, so today we're going to go over the derivatives of log functions. So with the derivatives of log functions, okay, we tend to look at y equals the ln of x, which is y equals log base e of x. So e to the y is equal to x. And if we take the derivative of this equation with respect to x, we have e to the y dy over dx equals 1, and dy over dx is 1 over e to the y, okay, which e to the y is x, so that's why dy over dx is 1 over x. In the case that it's not just x, it's u, we have the chain rule, we multiply by du over dx. Okay, so that was a quick deriving of our formula. Make sure you copy down our formula. So it's not only just this logarithm that we have, which is log base e of x. It doesn't have to be e, it could be log base a of x. Okay, so in that case, we could kind of go about this a different way. Make sure you copy down the formulas. So y equals log base a of x, so log base a of x is actually the ln of x over the ln of a. That's your change of base rule. So the derivative of this with respect to x, okay, so we get 1 over ln of a times 1 over x times 1. All right, basically, we're kind of pulling this out. This would be a constant. It's ln of, let's say, 2 or ln of 3. And we're taking the derivative of just ln of x, which we already established what that would be. Okay, and so that gives us this as our final answer here. Now, if let's say it's not just x, it's a, then that's where the u comes in the du over dx, okay, because we want to establish that there's a u there, okay, in the chain rule. So there's our formulas, and there's another thing we have to kind of keep in mind with logarithms, and that is when you're sketching a logarithm. Okay, this is a really bad drawing. The most important thing that I'm trying to emphasize is that vertical asymptote at x equals 0 for the ln of x or whatever logarithm. Okay, x cannot be 0, so that actually is our first step. Okay, we have to do our example here. So step 1 is to find the domain of our function. So we take the x plus 1, okay, and we want that greater than 0. Okay, you can't take the square root of x plus 1, you can take like the whole thing. But it's really x plus 1 that's greater than 0 still, and we solve this. So x has to be greater than -1. This is actually needed in part of our derivative. Now, if it's just x, you don't need to do step 1, but it's a good habit to have. Step 2, rewrite your logarithm. Okay, and when there is no e or 2, then it's a common log. It has a base of 10. So now we can take the derivative. It's derivative on the left side of the equation, and now the derivative on the right side of the equation. This is 1 over u times the ln of a times the derivative of u. That's supposed to be an x here. And then just kind of simplify it. That'll be step 4. So find out what x can be, rewrite your function, use your rule for derivatives, and simplify your answer. Make sure you have your full answer, which includes that x is greater than -1. Okay, logs have a restriction of their domain, so make sure that you include that in your answer. Okay, so we have 2 more examples we're going to do, and let's go. Okay, so a line with slope passes through the origin and is tangent to the graph of y equals ln of x. What is the value of m? So you have 2 different points, okay? One being the origin, and the other one being some x value. So usually x equals a. So I found the slope. Here's f of x minus f of 0 over x minus 0. And again, we could have left it in terms of x, but typically x is equal to a. It's some x value. So now, derivative, because now we found a line with a slope of m, and it's supposed to be tangent to our curve. So let's do the derivative of ln of x, and that is 1 over x. This is like our dy over dx. So if x is a, then 1 over a would be our slope here, because it's at a particular point, we just don't know where it is. And they're supposed to be the same. Okay, so we're going to set them equal to each other. And we cross multiply. Now, this is a logarithm, so we can continue to solve with logs. Actually, I'm going to divide both sides by a, so this equals 1. So if you have e and you raise it to the ln of a, you do the same thing with with the 1, so it's e to the first. This gives you a, and this gives you e. So the x value is actually e. Ta-da! Which isn't what we need. We just need the value of our slope. So if our value of our slope is the ln of a, and we just found out that it's e, this gives us the slope is 1 over e. That's our final answer for example 2. Okay, so you have to kind of establish what you're doing in example 2. You have 2 points that gives you a slope. Okay, one is the origin, the other one we don't know when x is 0, but we know what its y value is, so we made x equals a, and we compared our slopes. They're supposed to be the same because they're tangent to the graph, and we found our slope, it's 1 over e. So let's look at example 3. This is pretty straightforward, except we have to, step 1, take the 2 minus cosine of x, make it greater than 0, and solve. Luckily, this is true for all values of x. So we don't have a restriction, and we could just go about looking at our formula. We don't need to rewrite it either, but I'm just going to write what we have. And 3, take the derivative. So it's 1 over u du. And this simplifies nicely. Since there's no restriction, this would be our final answer. So sometimes they're pretty straightforward and kind of simple. Others, you have to think outside the box. Don't forget your 4 steps, and good luck.